The skies of 2025 will never be the same. A new legend is about to emerge, the SR-72 Darkstar. Once dismissed as a futuristic fantasy, it is now becoming a reality. But make no mistake, the SR-72 is far more than just another aircraft secretly developed by the US Air Force and top aerospace engineers. This is the future of hypersonic technology, a game changer that could completely redefine speed, stealth, and modern warfare. So, what capabilities will this aircraft bring to military operations? How could it reshape the way we think about offense and defense? Explore the SR-72 Darkstar, the war machine of the future, and why it is being readied for deployment in 2025. When the SR-71 Blackbird was officially retired in 1998, the US Air Force faced a major dilemma. The SR-71 was unmatched in intelligence, surveillance, and reconnaissance missions. Its withdrawal left a massive gap in America's strategic intelligence capabilities. They needed something superior, a worthy successor, and that's where the SR-72, also known as the Son of the Blackbird, comes in. The first rumors about the SR-72 began circulating in 2007 when reports suggested that Lockheed Martin was developing a high-speed successor to the SR-71. According to sources, this next-generation aircraft could reach an astonishing speed exceeding Mach 6, or more than 4,000 miles per hour. This isn't just a replacement, it's a quantum leap in technology, turning the SR-72 into a hypersonic weapon capable of striking fear into adversaries. For comparison, the SR-71 only reached Mach 3.2, meaning the SR-72 would be twice as fast, something once thought impossible. However, despite the speculation, most details about the SR-72 remain classified. A few leaked concept images and scattered bits of information have sparked curiosity among military analysts and the public alike. Yet, the US Air Force has remained silent, neither confirming nor denying collaboration with Lockheed Martin. Then, in 2013, a shocking report revealed that the US had decided not to fund the SR-72 program, leaving many wondering whether the project had been given the green light. But let's not forget, stealth technology once revolutionized modern warfare. Now, hypersonic technology could do the same. The SR-72 is equipped with an extremely advanced propulsion system, essentially combining 2 or even 3 types of jet engines into one. According to experts like Leland, the SR-72's propulsion begins with a conventional turbojet engine similar to those used in fighter jets like the Pratt & Whitney F-100 or General Electric F-110. This first stage allows the aircraft to take off and reach Mach 3, on par with today's most advanced fighters. But the real breakthrough happens when the SR-72 hits Mach 3, triggering its secret weapon, the second stage of its propulsion system. This is the dual-mode ramjet, which takes advantage of the aircraft's own supersonic airflow, channeling it through specialized air intake ducts to generate shockwaves, compress air, and boost efficiency. This technology enables the SR-72 to surpass the Blackbird's top speed and officially enter the realm of hypersonic flight. The SR-72's structure is engineered to withstand the extreme pressure and temperatures generated at Mach 6. Its airframe may incorporate cutting-edge composite materials such as ceramic matrix composites and carbon-carbon, capable of withstanding temperatures of thousands of degrees Fahrenheit. The aircraft's aerodynamics are also highly specialized, featuring a sleek, tapered fuselage and delta wings designed to minimize drag and enhance stability at hypersonic speeds. Additionally, the SR-72's flight control system may utilize advanced AI algorithms to automatically adjust control surfaces, ensuring stability and maneuverability at high speeds. Looking deeper into materials, CMCs are not only lightweight but also exhibit exceptional oxidation resistance at high temperatures, crucial for protecting the aircraft's structure from oxidation-induced degradation at hypersonic speeds. Carbon-carbon, primarily used on leading edges and high-heat areas, retains its mechanical strength even under extreme temperatures. Furthermore, engineers may have integrated phase-change materials into the aircraft's body to absorb and dissipate heat, helping regulate internal temperatures and prevent localized overheating. The combination of turbojet and ramjet/scramjet engines is the key to enabling the SR-72 to operate efficiently across a wide speed range, from takeoff and landing to sustained hypersonic flight. Heat-resistant composite materials not only shield the aircraft from extreme temperatures, but also reduce weight, enhancing both efficiency and maneuverability. What sets the SR-72 apart is that it does not rely on conventional jet engines. Instead, it is equipped with a turbine-based combined cycle engine. This represents a pinnacle of aerospace engineering, with the propulsion system developed by Aerojet Rocketdyne and the airframe designed by Lockheed Martin. TBCC is not just an engine, it's a highly sophisticated and complex system requiring seamless integration of multiple components. Its success could usher in a new era for hypersonic vehicles, not only in military applications but also in civilian aviation. To better understand TBCC, imagine it as a hybrid engine capable of switching between different operational modes depending on flight speed. At low speeds, the engine functions as a conventional turbojet or turbofan, providing sufficient thrust for takeoff and subsonic flight. Once the aircraft reaches Mach 2 to 3, the system transitions to ramjet or scramjet mode. This requires a highly complex network of air ducts, combustion chambers, and variable geometry nozzles to optimize performance at different speeds. The key point is that TBCC is not simply two separate engines placed side by side. It's a fully integrated design that maximizes the strengths of each propulsion type while minimizing their weaknesses. The greatest challenge lies in ensuring a smooth transition between modes, maintaining engine stability and efficiency across the entire flight envelope. With decades of expertise in rocket and hypersonic propulsion, Aerojet Rocketdyne has played a crucial role in solving these challenges. Ultra-high temperature materials, advanced control systems, and optimized aerodynamics are essential for TBCC to function effectively in the extreme environment of hypersonic flight. Initially, the SR-72 was designed for two primary missions: intelligence gathering through surveillance and reconnaissance, and striking ground targets with onboard weaponry. In May 2015, Lockheed Martin announced plans to employ the SR-72 for both roles. However, a major challenge arose. What kind of weapon could withstand the aircraft's incredible speed and altitude? Imagine this: a plane traveling at Mach 6 at an altitude of 88,000 feet, nearly twice the cruising ceiling of most modern fighter jets. Under such extreme conditions, conventional weapons and sensors would be virtually useless. This meant that engineers not only had to develop a hypersonic aircraft, but also had to create an entirely new generation of weapon systems capable of keeping up with its speed. And that is the greatest challenge in turning the SR-72 from concept into a true war machine. So, what do you think? Will the SR-72 Darkstar be a revolutionary breakthrough for the US Air Force, or just an ambitious experimental project? Drop your thoughts below, and let's discuss the future of hypersonic warfare. For the SR-72 to truly be a game changer, it must be equipped with entirely new sensors and weaponry to operate effectively under the extreme conditions of hypersonic flight. This isn't just an aircraft that flies faster than missiles and higher than most satellites. It represents a complete revolution in modern warfare. But to unleash its full potential, everything from its weapons to its reconnaissance systems must be reimagined from the ground up. The SR-72's sensors could leverage artificial intelligence to rapidly analyze data and identify critical targets with unmatched precision. Its weapons could be designed to engage targets on land, at sea, or in the air, giving it incredible versatility and adaptability. A key aspect of the SR-72's sensor suite could be its sensor fusion capability. Instead of operating independently, multiple sensors would work together to create a comprehensive battlefield picture, enhancing accuracy and minimizing errors. For example, a synthetic aperture radar, SAR, could map terrain and detect potential targets, while electro-optical, infrared, EO/IR sensors could merge with intelligence from other sources, such as satellites and reconnaissance aircraft, to create a complete and highly accurate intelligence picture. Additionally, the SR-72 could feature passive sensors capable of detecting electromagnetic signals from enemy radar and communication systems without emitting any signals of its own, maintaining its stealth advantage. Integrating artificial intelligence into its sensor systems would allow the SR-72 to automatically process data, identify threats, and suggest courses of action for its operators, reducing workload and enhancing combat effectiveness. Aerospace expert Leland emphasizes that the SR-72 isn't just fast, It's a true game changer. While it could launch hypersonic missiles, a more likely scenario is that it will carry cost-effective weapons optimized for its blistering speed. The hypersonic missiles currently under development in the US are highly advanced, with various designs in progress, but they come with an enormous price tag. The challenge lies in launching weapons at such extreme speeds, where pressure and temperature spikes make conventional deployment methods nearly impossible. Lockheed Martin has demonstrated this before with the YF-12, the fighter variant of the legendary SR-71 Blackbird. The YF-12 successfully fired air-to-air missiles while flying above Mach 3, but the SR-72, nicknamed the Son of Blackbird, takes everything to an entirely new level. If it truly reaches Mach 6, how will it reshape the future of warfare? Share your thoughts on the impact of hypersonic technology. What makes the SR-72 truly special isn't just its speed or firepower. It's its ability to gather real-time intelligence from anywhere in the world. This is especially critical in regions like the Pacific, where conflicts could span thousands of miles. Some may argue that satellites already provide global surveillance, but that's not entirely true. First, there aren't enough satellites to monitor every part of the Earth 24/7. Second, because satellite orbits are predictable, adversaries can easily calculate when to conceal sensitive activities. This is why the demand for reconnaissance aircraft remains high. Innovations like the MQ-1 Predator drone revolutionized surveillance, and even more advanced platforms such as the Northrop Grumman RQ-180, believed to operate at high altitudes while remaining stealthy, have proven the need for cutting-edge reconnaissance systems. However, despite massive investments in next-generation reconnaissance aircraft, most still operate at subsonic speeds, meaning they can't break the sound barrier. This makes rapid intelligence gathering a significant challenge. Take the MQ-9 Reaper as an example. It's a reliable drone capable of flying for over 24 hours, but its cruising speed is only 230 miles per hour. At that speed, it takes over an hour to fly from New York to Boston, and for a cross-country trip, New York to Los Angeles, it takes more than 10 hours. Not exactly fast when time is a critical factor. But if a hypersonic aircraft could reach Mach 6, it could complete the New York to Boston trip in under 5 minutes and fly coast to coast across the US in just about 30 minutes. Rob Weiss, Executive Vice President of Skunk Works at Lockheed Martin, the division responsible for the most advanced aviation projects, recently announced a major breakthrough. They successfully tested a turbine-based hypersonic engine for the SR-72, also known as the Son of Blackbird. Another significant development is that the SR-72 team is preparing to test a special prototype designed specifically for experimental flight research. This test aircraft, roughly the size of an F-22 Raptor, has a bold objective: to take off like a conventional jet using a turbine engine, accelerate to hypersonic speeds, and then switch to a scramjet engine to reach an astonishing velocity of Mach 6, faster than any aircraft ever built. Skunk Works is renowned for producing the most cutting-edge aircraft designs, and this project is no exception. By February 2018, Jack O'Banion, Vice President of Strategy at Lockheed Martin, confirmed that an SR-72 prototype had actually taken flight. In an interview with the Wall Street Journal, he revealed that the aircraft is remarkably agile at hypersonic speeds, and its engine is performing reliably, an enormous milestone for the project. Shortly after Lockheed Martin's big announcement, they swiftly removed all SR-72 information from their website and went completely silent about any updates. It was as if the project had never existed. But behind the scenes, Lockheed quietly continued pushing the SR-72 closer to reality. By the second quarter of 2022, Lockheed Martin reported a massive $225 million loss on a highly classified aerospace project. Yet, just 3 months later, things took an unexpected turn when reports surfaced that a customer had renegotiated contract terms and pricing, preventing Lockheed from shouldering the full financial burden. Despite that relief, costs continued to soar, reaching a staggering $335 million in losses. This strongly suggested that the project's budget had exceeded initial estimates, and all signs pointed to a large-scale, top-secret U.S. Air Force program. This isn't just a small experimental effort. It has officially moved beyond preliminary development into mass production, marking a significant milestone. A clear indicator of this shift is the construction of a new manufacturing facility at Lockheed Martin's legendary Skunk Works headquarters in Palmdale, California, known as Building 648. This cutting-edge factory is designed to streamline production timelines and costs, utilizing breakthrough technology such as artificial intelligence, augmented reality, and advanced Cobra robotics. These COBRA robots, short for Combined Operation Bolting and Robotic Auto Drill Systems, are powerful machines automating some of the most complex tasks in aircraft manufacturing. When the Skunk Works team first introduced them, they were working on the X-59 Quiet Supersonic Transport, an advanced supersonic aircraft designed to reduce sonic booms. But Skunk Works isn't just focused on one or two experimental projects. They have many other classified operations underway. From February 2018, when the SR-72 almost vanished from public view, to September 2023, Lockheed Martin significantly scaled up its operations. They ramped up advanced development programs by 75% and hired more than 2,300 new personnel to execute their ambitious plans. Skunk Works revealed that they had entered the low-rate production phase in 2022. John Clark, general manager of Skunk Works, confirmed that they were in low-rate production, though he couldn't disclose much due to security reasons. Clark emphasized that several top-secret and highly promising projects were happening right in Palmdale, a hub of aerospace breakthroughs for decades. Known for rapidly developing experimental prototypes, Skunk Works isn't just a research center. They've built some of the most legendary aircraft in aviation history, such as the SR-71 Blackbird and the F-117 Nighthawk. Clark explained that his primary goal is to prove that Skunk Works isn't just about prototypes, but also about developing practical aircraft that blend technological innovation with real-world operational capability. One of the most exciting projects is the SR-72, often called the Blackbird's successor. Do you think the nickname Blackbird's successor is fitting for the SR-72? Or does it need a new name that better reflects its power and breakthrough capabilities? If you have a better name in mind, drop it in the comments below. And if your comment gets the most likes, I'll pin it to the top. For years, many believed it was just an unfounded rumor, but growing evidence suggests it's real. However, not all news about the SR-72 is accurate. Some call it Darkstar, but that's not its official name. It remains unnamed, and Blackbird's successor is just a commonly used moniker. Interestingly, military aircraft often receive nicknames based on tradition, practicality, and historical significance. For example, the F-15 Eagle was named after the symbol of speed and power, the eagle. Until the SR-72 gets an official name, the mystery surrounding it continues to spark interest and speculation about its true capabilities. After the U.S. Air Force officially acknowledged the aircraft, the name Darkstar became more popular, especially following its appearance in the 2022 film Top Gun: Maverick. For the movie, Lockheed Martin worked behind the scenes to create an incredibly realistic aircraft model. They built a special prop just for the film, measuring about 69.5 feet long with a wingspan of only 5.5 feet. Some details, such as the cockpit control panels, were inspired by Lockheed Martin's actual prototype designs, adding to the authenticity. The model was primarily used for ground scenes, while flight sequences were created with visual effects to simulate takeoff and flight. Real FA-18 footage was used before being digitally replaced with the futuristic aircraft model. While Darkstar is just a fictional aircraft on screen, it's not entirely detached from reality. Lockheed Martin has been researching high-speed successors to the legendary SR-71 Blackbird since 1998. The SR-71 was once one of the fastest aircraft ever built, but developing a successor that can break past records is an enormous challenge. So what makes building such a hypersonic aircraft so difficult? As part of the DARPA Falcon project, Lockheed Martin's Skunk Works developed an advanced vehicle called the Hypersonic Technology Vehicle 2. This was a rocket-launched aircraft capable of reaching unimaginable speeds, far beyond anything we had ever seen. The SR-72 isn't just another aircraft, it's an unmanned vehicle designed to reach mind-blowing speeds. But more importantly, the SR-72 isn't just built for speed, it's a hypersonic reconnaissance machine designed to conduct surveillance missions at velocities that make it virtually impossible to intercept. When people think of the SR-71, they recall its secret reconnaissance missions. But with the SR-72, those missions will be taken to an entirely new level. One of the most formidable aspects of this aircraft is its ability to carry hypersonic missiles developed by Lockheed Martin. That means it could strike any target on Earth within just 1 hour, an unprecedented capability. With its blistering speed, the SR-72 can easily penetrate enemy airspace, complete its mission, and disappear before any air defense system has a chance to respond. In terms of sensor systems, the SR-72 could be equipped with advanced synthetic aperture radar and electro-optical/infrared imagery even in poor weather conditions or at night. Additionally, the SR-72 may carry electronic warfare systems to jam enemy radar and air defense networks, enhancing its survivability in combat environments. The SR-72's SAR system can use advanced signal processing techniques to generate 3D images of ground targets, even if they're hidden beneath foliage or structures. Its EO/IR sensors can employ specialized optical filters to detect small heat sources, such as vehicle or weapon systems. Meanwhile, its EW systems can utilize both active and passive jamming techniques to disrupt enemy radar and,